Hi everyone, welcome to my channel. Today we will create multiple linear regression model to predict income using dataset from Kaggle. You will find the link of the dataset in the description section of this video. Here we are creating Jupyter Notebook Multiple Linear Regression Volume 1 and giving heading of notebook Multiple Linear Regression to predict income. Then we are importing required libraries like pandas as PD, numpy as np, seaborn as sns, and matplotlib as plt. Further now we will read the downloaded CSV file from Kaggle. You can find the link to the dataset in the description section as well. I have renamed the file to Multiple Regression Dataset. Here we are using pandas, read CSV and creating a data frame df. Now let's explore the data frame and you can see three columns: age, experience and income. By using shape function, we are checking dimensions of data frame df. The data frame has 20 rows and 3 columns. Now we will check if the dataset contains any null values using isNull and sum function. As you can see in my screen, the 3 columns does not have any null values. In the next cell, we are calculating correlations between variables in the dataset. Correlation quantifies the strength of linear relationship between a pair of variables. Since we are performing multiple linear regression and we are using more than one variable as predictor, we need to analyze existence of multicollinearity. So now let's understand what is multicollinearity. Multicollinearity happens when independent variables in the regression models are highly correlated to each other. Then it creates an overfitting problem. Let's take an example to understand it more clearly. Consider we are trying to predict body fat by using variables weight, BMI and height. Weight is highly correlated with BMI and moderately correlated with height. Now we fit a model to predict fat by using all these three variables: BMI, weight and height. But BMI is function of both weight and height, so there is redundant information in these predictors. Hence, the model will show more inclined or influence towards weight change, and hence the model will not provide us correct output. To avoid this, we are checking correlationships between our variables age, experience and income. We are using data frame core function to calculate correlationship between the variables. Again, we are creating a correlation heat map to understand correlation between the variables. As you can see, the variables have significant linearity with income. Hence, income will be our predictive variable. Now let's define the variables of our model. For X or predictors, we are using data age and experience. And for Y as predictive variable, we are using income. To verify the dataset created, we are also using shape function to see its dimension. Now we are using sklearn model selection train test split to split data into xtrain, xtest, ytrain and ytest with test size of 30%. Now we will quickly check the values in these variables. Further, we will create linear regression model using sklearn linear model importing linear regression. We create a model LR model, then we use fit function using xtrain and ytrain and the output is linear regression. Hence, our model is successful. Now we will create variable ypred to store the predicted value from our model. We will use predict function to predict values of variable xtest. Now let's check the value of ypred. Further, to access the model created, we will evaluate our model using R-squared model evaluation. For that, we are importing R2 score from sklearn matrix. The R2 score of the model comes as 0.95, that is, our model is 95% accurate. In our next video, we will work with logistic regression with example. We have more exciting videos on the way, so don't forget to click subscribe so that you don't miss any content. Till then, have a good day and see you next time.